Hello, welcome to Machine Simulator Replicating a Real Machine tutorial. In this tutorial, I'm going to show you how to replicate a real machine with a machine simulator in order to simulate, in order to program the PLC for this system. In the left upper corner, you can see the real machine and the final result that at the end of the video we will learn to replicate, to virtualize. To this tutorial, we are going to replicate this kind of system. It's a gantry loader with a grip that loads boxes to boxes each time to loading in the wood pallet in a certain way. We are going to use the default tools that Machine Simulator has available, and also we are going to learn how to create our own devices for all these components that are not available but will need to replicate. Here we can see how there is a grip that takes boxes two boxes each time, takes the box and let it in the pallet. Now has already loaded one level of boxes and now starts with the second level in other position to give stability to the pallet. Let's start to program this system with Machine Simulator. Let's go to the editor and we are going to select Factory 1 editor. The strategy we are going to follow is we see that the system has a gantry loader with a kind of grip, special kind grip, has a aspiration system to take the boxes. We can see how there is a grip system that opens when download the, let's repeat, let the box, let the other box, opens the grip. The grip manage two different blocks to manage the two boxes separately. We see the gripper has a rotation system. We have the conveyor for the roller, also a transversal chain system to take the pallet to the load area, and other transporter for the boxes. Okay, we have a lot of devices available in Machine Simulator to replicate the machine. For instance, we have the gantry. We can use this gantry to reference system to load the boxes. We have the roller conveyors, and also we have available the chain transversal conveyors. For instance, this one is very similar to make the same function this machine has, to take the wood pallet to the lower position. For instance, we can use this roller conveyor also to move the pallet. Let's adjust. Okay. To create a small conveyor for the boxes, we can use from transporters, we can use, for instance, the small conveyor roller. Okay. Let's press EK to rotate. Let's select the small in order to remove the legs. And we can use it to transport the boxes. But there are one component that we have not available in the library. We have not this kind of gripper used by the real machine. Then we are going to use a very important flexible tool from Machine Simulator, that is the user-defined component, where we can create our own devices, our own systems, and give the behavior we want. The first part of this tutorial, I'm going to show you how to use the user-defined component to create our own devices. Okay, let's remove all the elements I have placed in the demo, and let's create our first user-defined component. I go to user-defined component, and I'm going to create a new one. Here I can place the name of the user-defined component, for instance, big grip. The category, here we can write we can assign the category where we want our component will appear. I can write a new one to create a new category in the list, or I think it's a good idea to write the robots, to use the robot category. I'm going to write robot. Then this component will appear in the robot category. Execute code. It means that if our user-defined component must to have a special behavior, we can program this behavior in the script code editor. I will explain you in advance. Okay, how we can add components to our user-defined components. We have the two different trees, the left hierarchy tree and the right user-defined tree. This tree is the area where we must to add all the components that will compose our user-defined components. For instance, I select a static element and is assigned inside the UDC component. But there are, in some occasions, we will need to have in our machines some components, for instance, to take a reference about scales, to take other kind of reference. Then I can add my components inside the machine in the hierarchy to take references, but they are not part of the user-defined component. Okay. Due the grip is associated, is linked to the gantry, I'm going to create our grip taking the reference of the gantry system. The objective of the user-defined components is to be reused in other machines, in other applications. Then we are going to create or use or gripper in this user-defined component alone without to be connected with no other system. But we in the future we will be able to accumulate this grip in other system. Due in our exemplar, we need a gantry with this kind of gripper. I'm going to add in our machine the gantry system. I only include the gantry in the machine to serve as reference to create our special gripper. But this gantry is not part of our user-defined component due is selected in the hierarchy machine. Okay, the first element we are going to create for a gripper could be, for instance, this plate. This plate, let's see, is the base of the gripper. I'm going to use element static. Due is a very flexible component that is very customizable. We can change the shape and we can configure to adapt to our necessities. I'm going to give the shape we need to be very similar to this final objective, this plate. Then we select the static component and we change the dimension, the physics scale to be as much as similar. For instance, I have already tested and I'm going to write the dimensions 0.05 in Y and 1.55. These are good values for the plate. Okay, these are could be the dimensions for the plate. Now let's place it taking reference the gantry. And I want to let the zero position of my user-defined components. I'm going to locate the gantry to the correct position in order not to change the zero position of the gripper of the user-defined component. Okay, the base, the plate of the grip, I think, is finished, and we are going to change the appearance of the plate. I'm going to change the texture of the plate. We can select a texture or a material. What is the difference between texture and material? The texture are flat images that has all information about color, but the material has more rich information, has the color information and also the reflection, the roughness of the material, and give us a more realism. Let's check material, and I'm going to select, for instance, the precious metal material. Okay, as you can see, has, for instance, the reflection, also information, reflects the light. Okay. Now, what is the next element we can add? Let's see the video. Okay, let's create this plate that is used to limit, to stop the boxes. Is in the left area, I'm going to add other static element, and let's locate in the correct position. Let's change the physical scale, for instance, 0.01, for instance. I think it's okay. 0.45 wide, 1.2. Okay, I think it's okay. It's in the left side of the grip. Let's locate as so much similar as possible. We also need to define the correct names in order to locate them correctly. I'm going to write, for instance, base, and we can locate faster. Let's change also the material for the plate. I'm going to search, for instance, the same material. Let's change a little bit the color, more darken. Let's select, for instance, something more like this type, also for the base. Okay, I think this looks better. Okay, we have the base, we have the left plate who serves to move the boxes. Now we are going to add a decoration element to link the base with the plate. Let's add a other static element, only decorative, to give the impression the plate is linked with the plate, then it's not collisionable. Has no sense to collide. Let's change the model, mechanical, and we select, for instance, the squad view. Now I'm going to place in the correct position. I press the E key to rotate. Let's move the correct axis, this position. Now I'm rotate. Okay. Now let's adjust the values accordingly. 180, 90. Okay, perfect. I press view key and I locate in one side to get the impression that is supporting the both plates. For instance, this position. Okay. Okay. View is not collisionable. I don't mean to see the scale of the physics scale. I'm going to write 0.1 to do smaller, and I'm going to rename, for instance, G1, for instance. Okay. Now I'm going to select and duplicate, Control D, rename G2, and let's place to the other side. Okay. Okay, we have this part finished. Okay. It's look like is joined. Okay, let's continue. Let's continue. The next element we can add is, for instance, the aspiration system. We see that this grip has an aspiration system that will take the parts and later download into the palette. Then next step is to add this aspiration system in our grip. Let's add other static element. I'm going to call, for instance, v.1. Then this really is a decoration element and will be not collisionable. We can reduce the physics shape, and let's assign a 3D model. I'm going to select from robots and, for instance, the aspiration system. Okay, perfect. Now we must to rotate the model assigned to this static element. Let's rotate 90 degrees and let's move to the base of the grip. For instance, this position a little bit in the side. Now, the grip can handle two boxes. Let's add other row of aspiration, and I think will be a good idea to duplicate to do two rows. Then let's duplicate, Control D. Let's change name to B2 and we move to the other side. Then it's necessary to adjust the scale of the model. I'm going to write 0.8 for the X axis. I move and the other one to 0.8. Only in X to adjust the length. Let's move a little bit. It's a little bit out. And then I'm going to move a little bit to center the aspiration. Okay. Let's change the camera views to select down. I select down position. I think it's okay. Now we can duplicate to make other row for the shock system. I locate Control D and other side. Okay, perfect. Let's change the name. Rename to one B and the other B2B. Okay. Let's reset the camera. And we have the two lines, the suction caps, that only has a decoration function. These components really don't take the parts, don't make the real suction, only has a decoration function. Let's place a little bit the support, the square, and the same for the other. Okay, I think this looks better. Okay, to recreate the aspiration, the suction system, we need a element that when will be in contact with a work part, uh, activates a digital PLC input to inform that the system is in contact with the work part, and also will be able to move with the grip. Then we use the hook element that is under the physics section. This element allows us to, when we are in contact with a word part, to activate a PLC input to inform that we are in contact, and also with a PLC output we can move the word part with the component. Okay, for instance, other decorative element we can add could be the wires, the cables, to give a more realistic effect. Let's choose a static element and oh, warning, I have selected all the user-defined component, then I have moved all, I selected the father, then I move all the children's. Then this is a decoration element, then it's not collisionable. Let's change the physics scale, and let's change the model property. Let's change the model, and we can see that in the lower side we have the checkbox component. If we click components, we have other kind of models of shapes. What is the difference between components and not components and models? The models are only 3D shapes that can be assigned inside the physics shape of the static element. But the components has their own shape. This means that when we select a component, a model component for the static component, the static element adopts the shape that will have this kind of component. Let's select, for instance, electrical and wire or cable. Wire dos, wire two. Okay. Now let's rotate E key, and if we press the zeta key, we can rotate step by step in order to search for the current value. Okay, 90. Okay, change position. Within this position is okay. Then change the name for cable 1, C1, Control D. This will be sheet 2, 180. Now 2070, and we place to the other side. Okay, now has the simulation of the, for instance, for the pneumatic whereas that only has the decorative functionality. Let's save our user-defined components in order not to lose all the work we have done until now. I select save user-defined component. By default is the same name I have written in the component name, and it's already saved. Okay, the next component we can create could be, for instance, the gripper system, cylinder, pneumatic cylinder that opens and closes. Okay, to do it, we select our user-defined component. I add a new static element and also will be a decorative element for the cylinder base. I'm going to change the physical scale. Then paying attention because it's very important to try to optimize our system as much as possible. Then if we are sure that this component will have not a physical behavior, it's necessary to not assign the collisionable property. I'm going to add to assign a model, for instance, pneumatics, this body cylinder base. Now I'm going to rotate E key. I press the zeta key. I rotate step by step. Now change to move. We can locate in the position we want, and now we need to change the scale, the model scale, to adjust the correct size. For instance, 0.69, 0.7 in Y axis, and in zeta we can write 0.6. Okay, I think it fits correctly. Let's move to the correct position. Okay. I think this is the correct position and the scale. Let's change a little bit the color, more lighter, and okay, this, perfect. Now is centered. Now the next element will be the piston cylinder for the cylinder. That is the element, the active element who moves the gripper. Now we must to add the interactive element that will be moved with the PLC output that will be moved opening or closing the grip. Also using a PLC input will be informed is the system is open or closed. Then let's add other static element that will be the piston. Let's call piston, and let's locate in place this position. Let's assign a model. This is the piston associated to the base. Let's change the rotation 90 degrees and adjust the scale to be similar to the base of the cylinder. Zero point 0.69, 0.7, and length 0.6. Okay, let's adjust a little bit to be inside, and we will be program this component to move when one PLC output will be received. Okay. This element also will be not collisionable because has not to collide. This component only will be translating the movement. We can change the physics shape. Okay, once we have done the piston that we'll see in advance how to move them. Now we are going to recreate the grip part, the arm of the grip, and later the grip bar. Now let's create the union between the piston and the bar grip. Let's add other static component. This obviously must to be a collisionable element because are going to collide with the parts. And here we must to add the correct shape, the proper shape. Okay, I think 0.4 is the plate, arm plate, to transport the movement from the piston to the grip plate. The objective will be that this plate will be moved together to the piston. Then we must to assign this static element. We must to drag and drop over the piston. Then we have made a parent operation. We have associated this component as child of the piston. This means that when the piston will move, also will move all the children or to all the elements that will be assigned as children. Okay. Now we'll change the texture, the appearance. Let's select materials metal, and for instance, this dark one. Okay. Now we have the arm. Let's create the grip bar. Let's select other static component. I'm going to rename to right side, and I parent to the piston to move together with the piston system. Okay, and the arm. This is also important, a collisionable component, and we must to give the shape, the physical scale to the shape. Um, 1.654. I'm testing the proper. Let's see the example. More or less must be the equal dimension, a little bit smaller than that base. Then must to be linked to the arm. See how the edge of the two plates must to be proportional. I think it's a little bit big. I'm going to reduce and instead to have the box, I'm going to assign a model to give a better appearance. I'm going to select mechanical, this this grip. Okay, as you can see, the shape of the model is very different. Then we need to assign the shape of the 3D model equal to the static element physical shape. Then we must to change the scale of the model, for instance 0.4, 2, 3, 4, 5, 6, too big, 5.8, perfect, and 0.1, 0.2. Okay, now we have matched the shape of the model. 5, okay, equal to the static element. Also, we need to change the color in order to fix. Let's change the texture of the model. We can assign a material and let's assign the same. Okay, now it matches the color and size of the model. Now let's start to program the behavior of the piston. The gripper must to be open and close when the gripper takes parts and when are downloaded in the pallet. We must to program this behavior. To program this behavior, we can do it by code in the user-defined script code. We can help by the help system available in the editor. We are working with basic say static elements. We want that when the PLC activates a digital output, will move the piston. Then we must to read the function to read a digital input. We can do it by means the IO manager and the function get output. We have several functions: init, main, physic, and finish. The init method will be executed only once when the installation starts. Mains will be executed cyclically while the machine is in run mode. The method physics is executed also cyclically, and here we must to program all these functions that requires high precision in the physics systems. And the exit finish will be executed when we pass from run mode to stop mode the simulation. Here we can write a function to read a PLC output. For instance, if I have the PLC output and the name of the output, for instance, we will write piston. Why piston? Because it's the name of the static component that we want to move. And we must to search the function that allows us to move the static element. For instance, animation move. In the help is explained what is the meaning of this function. Then I must write the direction. Could be X, Y, or zeta. In our case, must be X. We must move in X, and the speed That could be, for instance, one. And the target, the final position. For instance, then when the system reads the PLC output that is writing move, later will we see how to create, we will move, but we have other way to program this movement, this behavior. Instead to use the script code, we can use the controllers. The static element has the controller property, the controller's functionality, that where we can make the same, we can do programming, but instead of programming in a visual way. Here we write the name of the controller, a descriptive. What is the kind of this controller? In this case, I will select the animation move controller. Is not a collisionable element, then I must to choose the animation move. If the component will be collisionable, I must to select the move controller. In the help is explained all the controllers. What is the trigger who starts the movement? In our case, we want a digital output. What digital output? At the moment, we have not any defined digital outputs used by the user-defined component. Then now is a good moment to create all the digital I/O input outputs that the user-defined component is going to use. Here we can create the I/O used by the component. I'm click in Edit Digital Input, and now we can add all the need signal that we need to use. As inputs, what are the input we need? For instance, it's important the grip will detect when the bosses has been detected. We simulate that the grip has two detection system, photocells, inductive sensor switch, to detect the box presence and inform to the PLC to inform that there is an available box to take. I'm going to add a new input. I'm going to call, for instance, box 1 detect. Okay. By default, the system accessing the value 0 because we are in edit mode. When we'll be using the machine in the edit mode, we will be able to assign the physical address we will need. Let's add other input for the second box and other input to assign to inform about the state of the cylinder if it's advanced or retracted. Then, for instance, grip opened. That will be on when the piston will be activated. Now for the outputs, we will need, for instance, the aspiration for box 1. For instance, box 1 take to aspirate the first box, box 2 take to aspirate the second box, and other, and the third to open the grip. Open grip. Okay, with this PLC output, and we will move the cylinder, the piston. Okay, there is no need analogic I/O for this device, and parameters also there are not necessary. For instance, if we need that the piston will be moved some parameter, we can use the parameters. But in this case, we are going to move the piston in a fixed position. Now in the controller for the piston, now the PLC output that will be activate the cylinder, the piston is open grip. Okay, we can click here to choose from the available I/O we have written. And what is the direction we want to move? X, Y, or zeta? In this case, we want to move in X. What is the speed? Let's write one. Who is the amount of movement? I'm going to write 0.5, and now appears a kind of gizmo, blue gizmo, that will inform us the direction and the amount. If I change, for instance, for E, change the sense of the axis in zeta. This is a help, visual help to show us how the system will be moved. 0.2, because the amount to move the piston is a small quantity. We can add in a soundtrack each time is executed this movement, and this area is important. Pre-action and post-action. We can program an action to do just before and just after to move the component. In this case, we must to activate uh, input, a digital input to inform that the movement has been done. Then here we must write the PLC input we have defined in the user defined component, and the value will be true. Then when the movement will finish, then we will be activate the PLC input grid opened with a true value. Okay, let's test it. I press play. Now we see all the I/O, the digital outputs and the digital inputs that we have programmed here. And with the default values the system has assigned. These are not programmed, and okay, when I press is move. The 0.2 is the amount, and when has finished has activated the PLC input that we have defined. But when I remove the PLC output, nothing happens. Then we have to program now this behavior. Let's add other controller. We can do from here or from here. Okay, I add a new controller. I change the name, for instance, close grip. It's important to assign a descriptive name for the controller in order to search quickly and know what is the meaning of this controller. The type is also animation move. The trigger in this case is a digital output also, but now we need that the condition will be denegated, not to have the digital output. Then here is when we have not what? Open grip. Okay, now the same. I move X, speed 1, for instance 0.1. You must to go backwards, no sound, pre-action none, and post-action is important to reset the digital input grip opened to inform that the grip has been closed. Grip opened and the value will be false. Okay, if we let this, the system does not work because when the machine start this output is not present. Appears an error. Let's see. Due. The problem is I have written a comma instead of a point. We must respect the C sharp language characteristics. Okay, as a decimal separator, we must do. Okay, when I give play, as you see, the gripper has moved because there is not present the digital output. To avoid this behavior, we must to add a condition in the controller. When we start, doesn't move. How we can add a condition? We click the condition, we click an add condition button, and the condition could be R, could be or could be different logic bitwise conditions to make the comparison. We need an and condition. And what is the condition we will need to go backwards? The condition is very clear. Due when we advance the piston, we activate the digital input. The condition is to have the digital condition that we have the piston forward. Then I can select the condition is to have a digital input. The name here, I write the name of the digital input, name, grip opened, and what is the state, true or false. In my case, the condition is that will be true. Okay, then this controller will work. We need the digital output will be false, open grid false, and we need the digital input grip opened to true. Also, for the open grip controller, also we need a condition that will allow us to move in forward direction. Also, an and condition that is that the digital input grip opened will be false. Okay, when will be false, if the input is false and the output is activated, I can move forward. Okay, the position we must to return absolute. If we let 0.2 is the same position, then we must to change to 0.1. Okay, let's play. When I activate moves and we remove, okay, it works properly. Okay, and the output, the PLC input will be reset. Let me check 0.2. If we see the position, the home position of the piston is 0.0. Let's adjust to 0.09. Then when we return, we select the same position. Sorry, 0.09. Okay, then in this way we are sure we return to the home position. Okay, now we have writing the logic to move the grip, to open and close the grip. Okay, do this component are collisionables, will be push the boxes. Okay, perfect. Okay, the last component we need is to add the aspiration system. In order to make this functionality, we are going to add the hook system, the hook component. And I'm going to place in the shark, in the caps, aspiration caps position, in order to place this component in the proper way. I'm going to change the scale, for instance, 0.3 in zeta, and a little bit wide, 0.3, I think is okay, and a little bit more centered. We can do it more longer, but let's see from down position. Okay, I think this in the middle could be a proper location. And the system will do the following. When this component will be in contact with a work part, will be activate a PLC input. Also, when will be receive a PLC output, will be take the work part that is in contact and will be moved together with the component. Okay. To do this, will we use a controller? Let's change the name to the hook one, and let's add two controllers. The first controller is a control I'm going to call detection, and the controller is to check, to detect or inform we have taken. In this case is to detect. I'm going to assign to a one in PLC input. What input? The PLC input we have called box one detect. When the system will detect that is in touch with a work path, will be activate this input to the PLC. Okay, let's add other controller. I'm going to call, for instance, take. Obviously, take. What is the condition who will be activate this function? The value could be, I can write directly through false, but in this case, I want to associate this function to the value of the a digital output. Then I can write the name of the digital output. Box 1 take. Then when this digital output will be on, the hook system will be take the work part that is in contact. Okay, now we have finished this. Is due we cannot to see the shape, we can change the visible property. Then I don't want to see the shape of the hook. But before to change the visibility, I'm going to duplicate, clicking in the toolbar, duplicate. I change the name and let's see the down camera position to move in the other side. Now we can change the visible property. Then in runtime, we don't see the hook element, okay? But the functionality of the controllers of the hook will be working according we have programmed. Okay, once we have duplicate the second hook system, we must to change the IO for the second hook system. Box 2 to detect and to check box 2 take. Okay. The box 1 detect, box 1 take, and the 2 has box to detect and take box to take. Okay, perfect. Now we have finished the programming, the design of the special grip system. Now let's change our system works properly as we expected. To test the system, I'm going to add a work part in the machine in the hierarchy, and I'm going to change the type, the work part type, and the shape, physics shape. I'm going to place near the catch area. Okay, and I'm going to add a static component in order the box will not fall to the floor. Okay. Now let's start the simulation. Now, if I take the box, I press the control. Okay, we can verify how when the hook system detects will activate the PLC input, and for the other, okay, the same. When the box is detected, the PLC input is activated. If I activate the PLC output to take the parts, okay, we can verify how the box is catched, is hooked, and the same for the two. Okay, when it's taken, is caged and is released. Okay, we have verified that the logic works okay. Now we can delete the test elements, and now we can save or user-defined component. Okay, perfect. Now we can close the editor and we can remove the gantry. And now, if we go to user-defined components, the robot section, we can see the big grip component we have created inside there. By default, we will see a cube as the representation. The first time we have created, we need to restart the editor in order the component will be loaded properly. Now we can use for first time our user-defined components in our machine. Now we can see how all the I/O we have programmed are available. There are not analogic or parameter because we have not added anyone. If we want to see the image of the user-defined components in the icon, we can do the following. For instance, I click play. I'm going to save this screenshot, for instance, with the Windows capture screen feature. I press the Windows key to capture. Okay, and I save the rectangle to save it.
Y una vez capturada,
Now we
tenemos
must
que
to save
guardarlo
this file in the path where we have machine simulator, data, user-defined components, and we must to name it with the same name that has the user-defined component and the PNG extension. v.3 PNG. We save, we can close. I pass to the simulation to stop, and the next time we will be launch the editor, we can see how our user-defined component has already the image we have saved. Okay. Okay, once we have created our user-defined component, we can create the machine as much as possible similar to the real one. Let's add the Gantry system who will be manage the grip, and we are going to add the grip we have created. Now I'm going to place it in the proper position as if will be part of the gantry. Okay, a little bit adjusted. Perfect. I think this is a correct position. Now we want that when the gantry moves, also moves the grip as if the grip will be a tool of the gantry. If I, for instance, if I choose the gantry test mode and I move the gantry, obviously the gantry moves, but the gantry remains as a static element and does not move. To move the grip with the gantry, I must to select the gantry, and in tool name, I must to write the name of the element that we want that will work as the gantry tool. Then I name big grip to the grip. In the tool name, I write big grip. In this way, the system will be asking this component as child of the gantry in the tool. Now, if I press test mode, I play, see how this grip that we have choose as tool of the gantry moves together with the gantry. If I rotate the case 7/8, I can move with the case to move with more precision, and is associated to the axis of the gantry. Okay, I'm going to save the machine, my test for instance, and we save as my test. Okay, perfect. Okay, let's continue creating our machine, and now let's create the conveyor system. Let's create the conveyor to move the pallets to this, we can go to user-defined components, conveyors. We can use the two dirs big. This is a conveyor system that has a behavior very similar to the showed in the video. Due allows to move the with the chains to move the pallets that arrive from the other line and later to move in the rollers. We're going to use this component and let's place it as much as possible. Last will be place it to floor. We are not to use the legs of the conveyor due in the real system seems to be more placed in floor than we are going to do in the same way. Okay, this could be a good position. Then let's create the conveyor for the pallets in trans. Let's select this kind of conveyor. EK, zeta K, rotate step by step. Now WK, let's center in. Okay, let's move a little bit upper, not collide. Okay. Now let's duplicate, Control D, the conveyor, and we move in the correct position. Okay. Now we have created the input pallet entrance. Let's create the pallet. The pallet will be a work part because it's a part that must to be generated along the life of the simulation. And in the work part, we can select the pallet would be, and now we need to adapt the scale to fit the simulation. Physics scale, for instance, 2.2, 2.2. Okay, I think this seems correct. Okay. Now let's add the output conveyor for the pallet output. Okay, I'm going to add the same conveyor. And we must to adjust to fit in the correct position. Center it correctly, and let's duplicate, Control D to add an X module, and we place it forwards the other conveyor. Okay. Now we can test the conveyor system to check if it works correctly. We must to add to configure the PLC outputs. So we start, for instance, for this. It's a good idea to have a IO list to have all listed. In my list, I have the 9 PLC output. The same for this. For the 2D conveyors, I'm going to program the following PLC outputs. Advanced rollers, the 4, backwards to upper chain 6, down chain 7, advance is not necessary, and to move the chains the 8. Okay. These are the PLC output that we must to program in our PLC to move this transport. These conveyors will be used the 9 output, PLC output, and the same as this module. Okay. This conveyors has not PLC input, don't need it. Then now we can add a WordPad creator in order to generate the pallets. Let's place it in the proper position. I'm going to rename the pallet WordPad creator. And I'm going to assign the PLC output number 5, and creation interval will be 0. This means that in the moment that the PLC activates the PLC and the digital output 5, the WordPad palette will be created at the same moment. And the WordPad assigned is the 0 ID, and the palette has the part type ID 0. Then this WordPad creator will generate this WordPad. Now to place the correct position, I'm going to copy the position of the WordPad. I select the creator and I select the option to paste the position, scale, and rotations. I paste, then in this way moves in the same position. Now I see that the WordPads will be created in the proper position. Okay. Now when the machine starts, I don't want the WordPad will be shown. Then I remove the property on show machine start. Then the palette is not loaded. We must do OK. When we create the WordPad appears in the correct position, I will move the conveyors, the conveyor advance, the pallet arrives to the chain system. We must to elevate the chains. Okay. The change has been go to upper position. We advance the chains, and now we can move down the chain system. Then I must to activate this PLC output. Okay. Now I must to connect the conveyors, roller conveyor from the 2 directions. Okay. And the output conveyor. But we see a problem, and this view is not correctly adjusted. Then there is a collision between the 2 conveyors. Then I need to adjust a little bit. Then I select the conveyor. I'm going to move in this sense, move a little bit down. Okay, perfect. I think it's okay. Now I'm going to copy the position. I select the next one. I'm going to paste. I'm, I don't want to select the rotation, and I don't want to select the zeta position at only X and Y. Okay, perfect. And the position is configured correctly. Now let's check. I'm create a new work part. Let's activate the input conveyors. Now I'm going to move up the chains, activate the chains. I can stop, move down the chains, and connect the output conveyors. Sorry, no, this not. Connect this one. And okay, now it works properly. The conveyor moves the pallet in the proper way. Now we can add a work part destructor in order to delete the pallets with the boxes when arrives to the final position, and we must remove all the work part creator in order not to waste the memory and to enhance our simulation as much as possible. I'm going to scale the work part. Okay, let's save the machine. And now I'm going to create the conveyor for the boxes. Okay, I'm going to select the small conveyor. Okay, once located, I'm going to rotate 90 degrees. Then to rotate, I can press the E key and rotate directly with the gizmo, or I can rotate from the property grid, or if I have the component selected, I can press the E key to select the rotate gizmo, and in the lower position I can select the axis to rotate. In this example, I want to rotate in Y axis, and now I type the value with the key numbers and enter. In this way we can place, rotate faster the components. Let's change the component type to small, and let's place it to the floor level. Okay. I'm going to move a little bit more closer to the roller conveyor of the pallet. This position is okay. Now we can duplicate, Control D, and we can create it the conveyor for the input boxes. Control D, Control D. Okay, I think it's enough. Okay. I forgot to assign the IO, then I'm going to program the 3, please the output 3 for each one to move the conveyor box conveyor entrance. Okay. Now we add the boxes, our part. and I'm going to select the type. Okay, this one I think is very similar to the example. It's important the dimension of the box will be the same as the example in order to be able to create the same structure. The boxes must to have a proportional wide, edge wide, in order to we can create the same structure, the same shape when we download the boxes in the palette. Then to do that, let's make the following text. I move the palette in this position and the word part I place in the palette. I'm going to duplicate and rotate in order to create the same structure. Let's rotate 90 degrees. I move in this position, but to have the same proportion, the same dimensions, we need to change the scale of the boxes, for instance, a little bit and more longer, not so tall. Okay, I'm going to duplicate, Control D, A, V90. Okay, this position, let's check. Okay, we need to place other box in this way, rotate it 90 degrees. Okay, and the fourth one, Control D. If I move this position, okay, I think with this box dimension we can fit the same distribution as the example. I think this is the properly scale for the boxes to unload in the palette. Okay, let's delete these text boxes and I'm going to place in the final position in the conveyor, in the input box conveyor. Okay, this word part will be type 1 in order to be able to create with the word part creator. Okay, I'm going to place the word part in the proper position. I copy the position and I'm going to paste only in position. Okay, perfect. I'm going to move this box in this position, duplicate, create a second one, and let's rename properly any component. Word part box 1, word part box 2, word part creator. I'm going to name box per box. I'm going to assign the PLC output 3, the same as the conveyor, and the time is 3. Each 3 seconds will be created one box when the PLC output 3 will be activated. Okay, I mistake because in the type ET must to be created the type 1, not the 0. That is the palette. Then we have the conveyor that is moved with PLC output 3 and the creator word part with the same output. Then each time we activate the transporter, the conveyor, each 3 seconds a box is created. Okay, perfect. And now we must to add a system to stop the boxes. I'm going to save the machine and let's add a stop system. Now we are going to add other static element, static component, and let's change the model. I'm select components, mechanical, and let's select this one. That could be work as expected. To work as a stopper element. Let's place it more or less in this position. Now let's start the simulation, and when arrives to the stop, makes the collision and stop. Okay, perfect. Now we must to add the photocells in order to detect that the boxes has arrived to the loading position. Now I'm going to select the photocell in sensor. Let's place in this location. I'm going to select the small photocell type. Let's rotate 180 degrees. I'm going to remove the support property. Okay, in this position I think is okay. To detect the first box has arrived, I'm going to add a reflector system, and the distance for the reflector, let's choose, for instance, 0.84. Okay, and also the photocell range 0.8, I think is okay. Okay, the PLC input will be the 8, and once is the first one, I'm going to move, and I duplicate this photocell, Control D, and could be in this position to detect the second box has arrived to the final position. And I'm going to assign the PLC input number 9. Then let's check if works okay. Okay. Photocell 1 and photocell 2 for the second box. Okay, perfect. Now let's change The names for the first photocell, for instance, is W1. For the second is W2. Also, we need to rename the proper name for all the components, to adjust and search, be able to search it quickly when we work with the components. Descriptive components is a word part palette. Then we can find it quickly when we search in the hierarchy structure. This is the 3, this is the 4 conveyor. Word part creators, okay. The structure, only one, then it's not necessary a number. The conveyor roller, this is the 1, this is the second one, the third, 4, and 5. Okay, box 1, creator, box 2, and this, for instance, the name could be stopper. Okay, let's save it, and we will need more photocells to manage the palette from the input position to loading. Then let's add here a photocell to detect the palette sits outside the conveyor. Then we can start managing the conveyor chains. 2070. Let's change the type small. Here we can let the support, for instance. This position could be okay. Let's add a reflector and the distance for the reflector, for instance, 3. And the range, the distance for the photocell, 3 also. I'm going to assign the PLC input 10, for instance. Then when the palette will cut the photocell beam, we have the information to manage the chains. We will need other photocell located at the end of this position to detect the palette has arrived to the loading position. Let's rotate. For instance, could be more or less here. I'm going to assign PLC input number 11 and let's move a little bit. Okay. Let's test. It works okay. Then I'm going to check the show on start for the word part, and let's change the names of the photocells. SW3 and SW4. Okay, let's save the machine and test. Okay, here we have the photocell detection. Then now we elevate the chains, we connect, and okay, perfect. Here we can see how the photocell detects the pallet entrance in the door loading area. We have already all the sensors to detect the positions. Okay, now we will have all the matching ready to be simulated. We can simulate the application, but we need to assign the I/O for the gantry. We have the analogic I/O for the axis and the rotation for axis. We are going to manage with the analogic PLC outputs 0, 1, 2, 3, and we have the analogic PLC inputs that will return the current value of the axis in order the PLC will be able to know the current position. So 1, 2, 3. And the input to make the tool aspiration we are going not to use because we are going to use the ones for the grip we have created. Okay, for the grip, let's program the I/O. We select the inputs. I'm going to write for the digital inputs for the detects 1, 0, 1, and 2 for the open grip. And the outputs, the 0 for take box 1, 1 for the 2, and 2 for open the grip. Okay. Now we have all ready to be programmed by the PLC. But before we are going to program the demo program to show how the program must to be programmed. In the main screen, each machine has the possibility to launch the demo or to run the simulation. If we launch the demo simulation, the machine has not communication with the PLC, is in demonstration, and the objective is to show to the user how the machine must be programmed. We show the machine as it will be managed, programmed by a PLC. This is because internally Machine Simulator is executing the demo programming simulating that is managed by a PLC. In this way, the users can be sure in a quickly way how the machine must be programmed. You have the idea how the system must be programmed. Also, you can see the I/O to see what I/O are activated. I'm going to show you how to create this demo program. We are going to create this simulation program, this demonstration program. Let's open again the editor. We are going to open our machine, my test machine, and we're to create the demo program. To do it, we select in machine the edit script code, and we have several tabs. The first tab is where we can write the functions to give special behaviors to our machine. When we have seen the user-defined component, we have seen how to use this script editor, and in machine script demo mode is where we must to write the demonstration program. Here is the place where we can write the instructions to move the system in demo mode. Let's see that the way to do the trials is to write here the demonstration program, and once we have checked that the program works properly, we can paste in this tab. Okay. To be able to write the program, we need to know what are the positions the gantry must to go to take the parts and download the boxes in the properly positions. We can work in the gantry in test mode in order to move manually the gantry. We saw the window to move manually the gantry, and the glow sphere will be appeared. We can move with the mouse, or we can move with the keys 1, 2, 3, 4, 5, 7, 8 to move with more precision. Also, if we press the case pressing the shift key, the speed is reduced. Then we can move also with more precision for the final positions or precision positions. The speed is reduced pressing the shift key. We are going to do is when we move the gantry, we see how we see the axis value. Also, we have the possibility to program the gantry movements using the script functions. Instead to use the PLC analogic I/O to move, we can manage the gantry movements directly from the internal function the gantry provides us. To do, for instance, I'm going to go to the load position. I'm going to open the grid, and manually I'm going to place the gantry in the position where will be take the parts, the boxes, more or less. We can also to unlock the axis to move only the axis that we can move, we want to move. Then in this way it's more easy to move with precision the gantry in the position we want. Let's move in this position in order not to block the photocells, and with the grip open, let's place a little bit in this way. Okay, I'm trying to program the load position. I'm going to activate the conveyor. Okay, perhaps it's better to move a little bit. Okay, works better. One box detected, second box detected. Okay, and this position could be the correct one to take the parts. Then I can save the point. I'm going to rename this point to box load, and I save it. Okay, once the two boxes has arrived, now we need the the gripper will close, then we can move to the final destination. Okay, it's a little bit displaced. I'm going to adjust. And I return to the original position I saved. If I press the button returns to the position, it's a little bit displaced, then I readjust and pressing the update, the position is updated to the correct one that we need. Okay, now this is the home position. Now we must to go to the final position to take the parts. Then could be this one. Let's go down a little bit until the boxes will be detected. Okay, now the two boxes are detected. And now I must to close the grip. It's a good position. Then I can save as the box take. This is the position to take the boxes. Now we must to connect the aspiration in order to take the parts, the boxes, and we must to move in a safety position in upper, for instance this one, and from this position to move to the unload position. Then this position, box, take up. Okay, perfect. Now we can go to an intermediate position. From this position to download each box in the palette. Then this position could be box load in palette. Save the position. Now in order you can see how it works, I'm going to close. Let's stop the simulation. I'm going to save the machine and let's start. But the gantry must have been simulated in test mode. Appears the window to manage manually. I press the position to home position, I activate the conveyor. Okay, I forgot to open the grip. Okay, let's repeat. Gantry in test mode. Let's move to the load position. Let's open the grip. Now connect the conveyor. Arrives the first box, arrives the second box. Now we can stop the conveyor. Now we move the conveyor to the final, to the take position. Let's close let's activate the aspiration. We move up and we go to the download position. Okay, perfect. Now we can do is to move the palette to the download position. Let's move up the chains, activate the chains. Let's move down the chains, and now we have the system ready to download. Then we can start to program the position to download the boxes on the palette. Let's check how the first box was unloaded. Okay, in this position, and the second in this position. Okay, let's try to replicate. We can move manually the gantry to a similar position. I can also move with the keys 1, 2, 3, 4. Okay. Remember that we need to place one box here. We must to let space in the different position to let the boxes. Then a little bit from right. Then I move only in Y axis. Okay, I think here could be fine to download the first box. Then we can save this position as unload v.1. Okay, this is the position to download the first box. I'm safe. Okay. Now this box we must release. Now we must to get up the y-axis so much as to liberate the box in order when the gantry rotates do not touch the box. Then let's rotate in the same way the example to search this position. Then I rotate 7, 8 keys until search the 90 degrees. I press shift to search the position more precision. I block the I axis, the Y. I move only X and Z. Okay. Now I can move the Y axis and here. Oh, no. I have mistake. In this sense, will collide. We must rotate in the other sense in order not to make the collision with the grip. It will be the other sense in order the plate will be in this side of the boxes. Let's search for the correct value. 2070. Okay. The plate is in this way. Okay. Let's move X and I, X and Z, and now only in Y axis. Let's block. Let's move with the keys. I press shift to go slowly. Okay, I think this is a correct position to let the second box. And I can release the box. Okay, the box has fall. And now I can save this position as unload box 2. Okay, I save it. And we have already programmed the box 1 and box 2. This process we have to repeat for all the boxes 3, 4, for the 2 boxes for the laterals, for the level 1 and the level 2. In order not to make the video so long, I'm going to do the positions and later I will show you. Okay, once I have programmed all the positions to download the boxes into the palette, to do the test, I'm going to show the work parts in this place, then and avoid to transport. Then let's check how to work. I'm going to position 1, to position of load. I open the grip, I connect the conveyor. So once has arrived the 2 boxes, I close, I move to the final, close the grip, go to the load position, we activate the aspiration, and we move to the upper position. Now the first box download, we release part 1, go up, download second part, go down, we release the part, we go up, and home position. Okay, now we go other time to the load position, we open the grip and activate the conveyor. Stop, position, load position, close the grip, down, aspiration 1, 2, upper position, and we can go to the 3 box, download, go down, release part 1, move up, go to the 4th download position, go down, we release the part, we move up, and we can go again to the home position. Okay, and so on for all the positions until complete the two level of box appearance. Okay, now we have all the positions. Now we are ready to create the demo program. To create the demo program, as we have seen before, I'm going to select the word part to let in this position. I click edit script code, and in main script code we can start to write the program. Once will be work correctly, we must to paste in the demo. Let's create a integer variable called sec, and let's initialize as to 0. We can import, clicking in this icon, all the I/O signal used by our machine. All the I/O are imported in our code in order to use the I/O in a very easy way, instead to use numbers, to use a description more easy data number. Now I'm going to call a function that always we will be in run mode, call automatic mode. For instance, here we create the function automatic mode, and I'm going to use a switch case structure in order to sequentiate all the instructions. We write all the cases for the value of the sec variable. In function of the value of the variable, we can sequentiate all the actions we will need. First, we are going to manage the input palette. We are going to program that the palette arrives until the download area. Then in the first sequence, we must to activate the digital output for the palette activation. Then I'm going to use the help. We are going to the IO manager and I choose the set output. If I click, I make double click in the function appears in the code. Here we are going to write the number of the output. Then I can go to digital IO and here are listed all the IO used by the system. Then the palette, the word part creator used this IO. If I double click, if I make double click, the name is included and the value is true. Okay. Then we are creating the palette in the first case. Also, I must to create the output to move the input conveyor for the palettes. That will be the 7. I make double click, sorry, this is not okay. It was this one. Okay. And when the palette detects the photocell, the BAM photocell, we pass to the next step. Then if we have the input, we use the get input to read the digital input that in this case we need for the photocell that will be the 3, double click. Okay, then in this case we must to advance the sequence. Okay, we pass to the next step. In the next step we must to do the following. The sequence 1, we are going to wait until lose the signal of the photocell. When we have not the photocell, we can stop to the next sequence, letting the conveyors connected. Okay. In the next step, we are going to deactivate the input conveyor. We deactivate the creation word palette, and we activate the advance the chain at the upper movement. When the photocell that is located at the end of the conveyor, we can pass to the sequence 3. In the sequence 3, we can write the following code. Then we stop the chain movement. We move down the chain, and we need a new Boolean variable called palette. And in this point, I'm going to write palette equal a true. This means that one palette is located in the download position, then the gantry knows that it's ready to download the parts. Then when the gantry has already loaded all the palettes, can enable the permission to advance to the step 4. And in this step, we can activate the conveyor, the output conveyor, be sure the chains are down, and we activate the conveyors to release the pallet with the boxes. Okay, let's save. We see one compile error. Let's check what happened. Yeah, if we go to the tab error, we see that it's like a parenthesis. This close here, let's close it here. This goes with this. Okay, here is a parenthesis other, and I need to write another one. Now, okay, here in the 75 line is indicated the error. We save, other error appears. Let's correct. Sequence 1 doesn't exit. Okay, I must write here sec1, save, another error again. Let's check sec1. Okay, here I must type sec1 also. Save. Okay, compilation okay. Now it's ready to execute the program. Let's check if this part of the program it works. Okay. Okay. When we lose the signal, the chain moves up, and when the text moves down, and the gantry and the system is waiting. Okay. Now we must to program the part of the gantry. To do it, we go to edit the code. And now to program the gantry part, we need other sequence. Let's create other integer variable sec2. Here I'm going to use other switch case sequence to manage all the gantry loading and unloading section. Then once we have taken the boxes to go to the each downloading position, but there is always a sequence that are going to be repeat. Is the sequence to go to two new loading boxes. I'm going to program this in the sequence 3. Then we need a new integer variable called sequence 3, and this sequence we are going to use to go always for two new boxes. This sequence is used to download the two boxes we have loaded in the palette, and this sequence is used to manage the palette to the download position. This will be great later. Now we are going to program the part to go for two new boxes. Here we can program in the following way. In the sequence 0, we can type gantry, that is the name of the gantry we have used. We go to robots gantry node, and we search the function go to point. I may double click. This function allows to move the gantry to the position we have saved in the test function. And the speed the gantry will be moved. The name I have written is home for the position, home position, and sec 3 is equal to 1. I can pass to the next case. Case 1, we must do wait until the gantry has arrived to the desired position, to the position I have read. Then I type if gantry stopped. This means the gantry has arrived to the position we have programmed. Then we advance the sequence. In the case 2, we can program the following. We activate the grip, we open the grip, we activate the box activation creation and the box connection, and if we have the signal of the first photocell and the second photocell, then we can advance in our sequence. In the case 3, now we can type the following. Once the boxes has arrived, we stop the conveyor and we move the gantry to the position 1. And we can pass to sequence 4. Once we move the gantry to this new location, we must wait until has arrived. Then we can pass to the next position, next step. The next step is to close the grip, and we wait until the grip is closed, reading the digital input. In this case, we advance the sequence. Now, in the following step, we move the gantry to the position 2 to check the boxes. We advance to the next sequence. Case 7, we have to wait until the gantry has arrived the position 2 we have selected. In this case, we advance the sequence. Case 8, we do the following. Once the gantry has stopped, then we check if the grip of the gantry detects the first and the second boxes has detected. Then we activate the aspiration and we activate a timer. To use a timer, we go a machine simulator object and we choose the set timer that has 2 parameters. One, the name of the timer. I'm going to call 1 sec, and the interval in milliseconds. I'm going to write 1000, that is 1 second. And now we can advance to the next step. Now we must to wait this timer has finished. To do it, we must to use the function get timer, where we must to write the number of the timer to be read. Then when the timer expires, then we must reset this timer if we want to reuse, as is the case, the name of the timer, and we can advance in the sequence. Sequence 3 equal a 10. Step 10. In this case, we can move the gantry to the next position. The position I have called 3, that is a intermediary position in the elevated position. Then in the case 11, okay, it's the same operation as before. Wait until the gantry has arrived to the position. In case 12, I'm going to let left empty in order to check the gantry, the program is okay. An error appears. Let's see what is the error. Okay, let's check the line number 166, and okay, I have repeat the ms 2 times. I save and the compilation is okay. Now we can test if it works until now. Okay, wait until the 2 boxes. Okay, let's go to the 3 position, and it means that works until now. Now we have to write the part of the code that will unload all the boxes in the palette. We have done how is done. Then I'm going to do in a quickly way in order to not too long, not to do very long this video. Okay, I just written all the code. I have programmed all the positions to go to download all the boxes in the palette. Okay, starting box 1, 2, now box 3, 4, now boxes 5, 6, box 6, 8, 9, 10, so on to the last 23 and 24. And with this code, theoretically, we have done all the programming showing how the machine must to be programmed in the demo program. Let's test it. I'm going to advance the video to do the demonstration faster. We see how are downloading now the first level, and now the gantry goes to download in the second level. Okay. Okay. Now 2 boxes, 2 boxes, 2 side boxes, and the 2 and the last one are the last 2 one. Okay. Perfect. We have seen how we have created the demo program and works okay. Now we must do the following. We must copy all this code and we must copy and paste in Machine Simulator demo program. We paste. Okay, then this code will be only execute when the machine will be initiated in demo mode. Now, in the Machine Simulator code, we must to remove all the code used in demo, and we want not to be executed in normal mode connecting with the PLC. I remove this and all this. Okay, now we let only these 4 functions that always must to be present in each machine, and in the demo is writing the demo program we have already tested. We must to save, and lastly we can define the camera positions. We can assign to the keys by default. We select the set cameras position. By default are all to 0, and we can go to the decided position. When we press the buttons, the camera is safe in this position. Then if we press the key 1, the numeric keys 1, 2, 3, 4 until 9, the camera travels automatically to this preset camera position. Also, if we press the 0 key, the camera will travel around these points. If I press key 1, key 2, key 3, or if I press the trip camera, the camera will travel automatically for all the positions we have configured, and then we can center in only in the simulation. Okay, now we can go to the main menu. We can go to machines, and we will see that our machine has not a preview image because we have not configured. Let's open the editor and let's open our machine. My machine. We can change the machine name. Right, the author has created the machine, and the description we want to appear in the main menu. Box palletizzer, for instance. Okay, if I press play, I want to choose a correct position. I press the 11K, then automatically a screenshot is saved for the machine, but it's better to hide the I/O panels. I repeat, pressing F11 to make a screenshot of the machine. Then when we go to the start and we search our machine, we can see our machine, my test, with the image. If we press the demo button, we can see how the machine starts to move, and in this way is explaining how the machine must to be programmed. If we press start mode, then in this way the machine is ready to communicate with the PLC, and the management of the logic will be done by the PLC. Also, if we want to write a description of how the machine must to be programmed, we can we can press the machine's characteristic, and in the text box we can type all the description we want to explain to the users about this machine. We can save, we can exit and go to the main menu. Then in machines, if we click over our machine, when we make click, appears the description about our machine. Okay, it is all for this tutorial. I hope it has helped you. Thank you for following it. And in case of question, I suggest you to use the Nirtec forum or consult our website. Thank you very much.